Hello, everybody. My name is Roy Panetta, and I'll just start by going over the agenda for today. And first of all, I'll describe what is load balance route policy. Then I'll just talk about why Draitec have modified the load balance and route policies, and then what are the new features, and talk a little bit about address mapping, and then give some configuration examples. So first of all, I'll just start by describing what load balance route policy is. So I'll just go to the next slide. So Cisco referred to this as policy-based routing. So it's similar sort of features. And what it is it's a feature where there's a set of rules or policies that are defined first, and then if the data packet arrives and matches any of the configured policies, it will be directed to this specified interface. And then in this diagram just below here, it just shows you one example where any traffic from LAN 1 is shown in green there, and that's is directed through to the internet through WAN 1, and traffic from LAN 2, shown in blue, is directed to the internet through WAN 2. So just a very basic application. And you should note that the load balance route policy should not be confused with the load balance mode that is configured in the WAN general setup menu. That's just shown in the page just below here. In this mode, traffic is distributed over multiple WAN interfaces to provide greater bandwidth or to provide redundancy if a WAN interface goes down. Okay, and you should note that WAN load balance policy mode will have a lower priority than the policy settings in the load balance route policy configuration. And the new firmware, or actually the new router firmware, has added a number of new features to the load balance route policy. And this is shown on this page, and these are adjustable priority for load balance route policies. More interfaces can be selected. The source, destination, and IP subnets can be selected. And also got flexible failover to the WAN, LAN, and VPN. And also there's a failback option. And but I'll go into more detail about these features later on in the presentation. So I'll just go to the next slide. Okay, so now we'll just start to talk briefly the reasons why Draitec have modified the load balance route policy. So in the past, the load balance policy overrode the interLAN routing configured in the router. We can use this diagram shown here to describe what is happening. So you can see you've got LAN 1 and LAN 2 and the router with two WAN connections. So if you have a dual WAN router and also has two LANs configured, and say we had servers on LAN 1 and PCs on LAN 2, then so we can configure the load balance route policy as shown on this table on the right here. And here we have LAN 1 traffic going to use, so going to use WAN 1, and LAN 2 is going to use WAN 2. So this is a basic load balance configuration. But since you've got servers on LAN 1, PCs on LAN 2 will sometimes need to access the server via interLAN routing. So let's go. So the problem occurs if I just go to the next slide. So the problem occurs that since the load balance policy is directing traffic to WAN 2 for the PCs on LAN 2, it will override the interLAN routing. And the result is that PCs on LAN 2 will not be able to access the server, which is on LAN 1. So what Draitec have done, actually what you need to do with the old setup is, so to overcome this, we need to create an additional route policy for LAN 1 to access LAN 2. And this is going to be the first rule, and that's shown here under index 1. And since the rules are running in sequential order, you need to place that at the very top. So this is okay, but you find that when it can get a bit complicated later on. So as you can see here in this diagram, if you have multiple subnets, you will need to create multiple rules to cover all of the required paths. And this can become cumbersome. So Dratek developed a new feature in response to requests from customers for the ability to decide the priority between the routing table and the load balance route policy. This way, the load balance route policy will not override the interland routing anymore. Hence the release of this firmware that has this new feature. And I'll just go next one. So I'll just quickly go through what the new features are in this load balance route policy. And the new load balance route policy is available in the router shown on this list here, and the firmware version when this will become available. So the list includes the VIGA 2760, 2860, 2912, and 2925. You should know 2760 is a simple WAN router, but the new load balance route policy does include routing to LANs and VPNs and DNZ, so it will apply to this router as well. And this firmware is not yet available, but will be in the future for the 2760. So, but I'll use the VIGA 2860 and VIGA 2925 routers in my discussion today. In the older firmware versions, the load balance route policy is, as you can see in this picture. So you just got the, just what you're probably used to, just the protocol interface and source and destination IPs and the ports. But in the new firmware, you notice there's additional columns there. So, but it has been improved. So when you go to load balance route policy, you'll notice that you can use the wizard mode or advanced mode to configure the load balance route policies. The wizard mode provides a simple and basic configuration, and it will guide you through the configuration process. The advanced mode provides all the options on one page and provides more options. You can notice from this picture that they have added the priority setting as well, which is the probably the fourth column. So you've got priority. But I'll go into more detail later on for this one. So I'll just show you, these are the features you got in the older firmware. So you probably, there's not many choices there. And you can see it's got limited, it was limited just to directing traffic to a particular WAN or LAN interface. It also included the auto failover to another WAN interface if the selected WAN connection had gone down. Now in the latest firmware, the load balance route policy has been improved. So when you go to load balance route policy and in the general setup menu, you will notice that the use of the wizard mode or advanced mode to configure the load balance route policy. So so you can notice in this picture I've added the priority setting, which is towards about the 2/3 of the way down. It's a bit hard to see though, but it's there. So now I'll just show you the old menu on the left, and on the right-hand side we've got the latest version. And you can see that there's a lot more options have been added to the new firmware, which is on the right-hand side. And I'm not sure you can see this on the right-hand side. The protocol options remain the same, but you can select from any TCP, UDP, TCP, UDP, and ICMP. In the new version, the source IP address option lets you select the whole IP subnet, and you can select one of the predefined subnet masks to specify the IP range. So for send option, actually it's called send if criteria matched option in the older version. The WAN, LAN, and VPN options are all in one pull-down menu. And you'll notice that in the new firmware on the right-hand side, that now the WAN, LAN, and VPN options are split into, make it a bit easier for you to select the required option. And the interfaces you can select include WAN, LAN, IP routed subnet, and DMZ subnet. And also now VPN trunks are supported, so you can choose the required VPN trunk member in the VPN profiles. And here you can see you can select any of the pre-configured, any of the configured VPNs for the interface you want to direct the traffic to. And you will notice that in advanced mode that there are more options available. And these are ForceNAT, force routing, failover, and failback. You can see them just, I had like a red box around those options. So failover and failback options are now available in this new firmware, and in the older firmware, only failover to another WAN was available. Now in the new version, failover, it's more flexible. You can failover to the default WAN or LAN with the designated gateway. You can also failover to a VPN trunk or failover to another route policy. So you can have many layers of failover that you can use. When the primary WAN is specified in the load balance policy fails, traffic will be directed to the second WAN selected in the policy settings. So now I'll just quickly talk about failback. And there are two options here. The first is immediate failback, and as you will be able to see in the menu, existing sessions existing sessions affected by this policy will be cleared immediately when the original interface comes back online. Any new sessions will need to be established on the new WAN when it comes back online. You may want this if you want to fail over to a 3G or 4G network where data charges are high and you want to minimize data usage charges. And the other option is gradual failback. So here you do not select failback, and sessions will end normally on the backup interface. And new sessions go through to the original WAN when it comes back online. But it may take a while for all the traffic to move to the original WAN. Let's go to the next one. And the last new feature I'll mention is the adjustable priority option. And this option lets you select the priority of the load balance policy rule. A lower number will have a higher priority. So on the right-hand side, you've got 0, which is the lowest, and 250 rather is the highest. So but the priority settings can be between 1 and 249, and determines the order the policy rules will be implemented. So as mentioned earlier, the lower number has higher priority. If two rules have the same priority, say at 200, which is the default setting, then the rules will be implemented in sequential order, which will be top to bottom. You should note that routes in the routing table in the router, including configured static routes, have a priority value of 150, which is just highlighted there. It's in the middle. So a priority setting of less than 150 for a load balance priority rule will override any routes in the routing table. So for the original example I showed you at the beginning, we had to include a load balance route policy for the LAN interface. So now we can just specify the priority for WAN 1 and WAN 2 to be lower than that of the routes in the routing table. So we assign the value of 200, which is less than 150, which is the priority of the interLAN routing table. So the result will be that fewer rules are required. And as you can see here, only 2 rules are needed now to, for the same example we showed at the very beginning. So now I'll just quickly go over address mapping. That's another feature in the load balance route policy configuration menu. Yeah, address mapping was a separate menu option in older firmware versions. Now in the later firmware versions, it has been integrated into the load balance route policy. Address mapping is used to specify an outgoing IP address for a particular device on the LAN. This is used when you have a block of public IP addresses in the router under WAN IP aliases. So you can see, I'll just show you quickly the steps to configure address mapping with route policy. So first you will need to have a block of IP addresses entered as WAN IP aliases in the router. So that's what I was just showing here. So as you can see here, we have 2 IP addresses entered. These are 172.17.1.1 for index 2 and 172.17.2.2 for index 3. And you have to remember not to join the NAT IP pool option. So it seems like it won't work for these 2 addresses. These 2 IP addresses will appear in the pull down list in the route policy setting. So now we go to the load balance route policy menu and enter the source IP address for the devices in the LAN that we want to use the outgoing, specify the outgoing IP address. So here we have entered the IP address, actually put the range in 192.168.1.20 to 192.168.1.30 as the source IP. And then we select any for the destination IP. And then you can see sort of 2/3 of the way down, we got, we under send to if criteria matched option, we select WAN 1 for the interface, and then select the first WAN PI alias, which is 172.17.1.1, and also use the default gateway. We can also select auto failover to another WAN, so the traffic will be sent via another interface when the path fails. But if you not enable this option if you want traffic to only use the designated IP address. And then we just click OK to save, and that's what we have to do. And now any traffic going out to the internet from the computers in the range 192.168.1.20 to 192.168.1.30 will have the outgoing IP address of 172.17.1.1. So now I'll just quickly go over some configuration examples where we use load balance route policy. So this will be a couple of simple examples. So I will just start with an example using the most common function, and that is to direct traffic from a source IP address or a range of IP addresses to the selected WAN interface. Let's have a drink. So, for example, you may have a mail gateway that only accepts SMTP mail from its ISP. So SMT mail has to go out through this ISP's WAN connection. So for example, you may have an Internode ISP connection on WAN 1 and WAN 2 is connected to a Telstra, but the SMTP gateway is on the Internode network. Then in this case, you may want SMTP mail to always go through WAN 1. An easy way to configure this is to have all traffic from the mail server, which I just got shown in the diagram as 192.168.1.10, to go out via WAN 1. So we set the protocol to any and set the source IP to be that of the mail server, which is 192.168.1.10, and have the destination set to any. But for the interface setting, we select WAN 1 as the default gateway. And I think I've got this here on this next slide here. I've got the settings. So that's the settings for that. So that's a fairly simple example. Now just go through another example here. And here we want a range of IP addresses, which is 192.168.1.10 through to 192.168.1.100, going to a destination IP address of 8.8.8, and then regardless of the protocol used in the destination ports. And we also want this traffic to go through VPN 1, which is called Dratek. So I'll just show you the configuration menu. So first of all, we'll need to select the first available index. So we can choose index 1 here. Actually, I've got index 2 shown. But anyway, now set the protocol to any and set the source IP address range starting at 192.168.1.10 and ending at 192.168.1.100. I think my screenshot's not quite correct there. So for the destination IP, we enter the start of the IP address range to be, which is 8.8.8.8. And as we are only looking at a single destination IP address, and for the destination port, we select any. The last step is to select the VPN as the interface. So you can see that it's just under D on the diagram, on the picture there. We select VPN 1, and we'll use the we'll use their default gateway. And just a quick final example. Here we want to have LAN clients in the branch office to access the internet through the head office router via the VPN tunnel. So here we can configure the route policy in the branch office to make this happen. So we just show the settings here. So as you can see here, we enter the branch office IP address as the source IP address and select the destination as any. For the interface, we select LAN 1 for the gateway and enter the IP address for the firewall router for the headquarters network. And the last step is to set the priority to a value less than 150. So this policy will have a higher priority than that of the routes defined in the routing table. So that way it'll override the VPN have higher precedence.